Alright, so here is Quideo number 1. In the basic question, it says, in 1993, Forbes magazine reported the age and salary of the CEOs of each of the top 59 small businesses. And it gives the salary data right here, and they are all rounded to the nearest $1,000. So it says to construct a histogram for the data. So looking at the data, the lowest number was 21, and the highest number was 1,103. And using that, you can split the intervals to make the histogram into intervals of 100. And then you count how many are in each interval. And when you do that, you can make your histogram. So when you make the histogram, the title is Small Business CEO Salaries in 1993, and the x-axis is the salary in thousands of dollars, and the y-axis is the number of CEOs that made each of those salaries. So the second part of the question asks to describe the shape, center, and spread of the distribution of the CEO salaries. So the shape of this graph is skewed right. There's a lot more data on the left side of the graph than the right. And to verify that in the calculator, you can go ahead and enter in all of the data into Stat and Edit. And I've already done that for all 59 of the CEO salaries. And then once you do that, you go to the Stat, Calc, and hit Enter on the very first one. And then using the first list, so you have to change this to first list. And the frequency list, we don't have one. So then you just hit calculate. And when it does that, it'll give you the mean, and the median will be right here. So the median is $350,000 and the mean is $404,000. So they are very far apart, and the $404 thousands of dollars is pulled more towards this tail right here. So knowing that the median and the mean are not near each other on this graph verifies that it is skewed to the right. When looking at the center of the graph, since it is not symmetrical but instead it's skewed to the right, the median will be a better measure of the center since it will not account for any of the outliers or the skewness of the graph. So since the center is the median, we found that in the calculator to be 350,000. So right here, and even if I wasn't to use the calculator, you could still tell that this is where the data is split in half, just because there's this tall interval right here, and then there's a lot of short ones on this side. And then the spread of the data, or the ranges from $0 to $1,200,000. And more accurately, it, as we saw here, the lowest number was $21,000 and the highest was $1,103,000. And so there is a large range on that spread. And the outliers is the last thing that the question asks for. So it looks like there's a potential outlier right here at the very end of the graph, and that's because there's a gap in between it and the rest of the data. So you can verify that that is an outlier by finding the IQR. And so in the calculator, if you look at where you go to Stat and Calc, and when you look at this, if you scroll down, you can see the Q1 and the Q3. So the Q1 is $250,000 and the Q3 is $543,000. So using that, you can find your IQR by just subtracting the two, and you get 293. And then to find the outlier range, you just have to multiply that by 1.5, and you get $439.5 thousand from the median is how far out an outlier could potentially be. So when you add the median to your IQR outlier range, then you get 789.5 and over are your outliers. So looking at this graph again, the 789.5 is in this 700 to 800 range. So anything above the 800 range is definitely an outlier. So we actually have we know 5 outliers because there's 4 here and then there's this one. So this is definitely an outlier, and then we also have found that there's actually more than what we thought. So the next question is the advanced question, and it says, in 1864, a published paper provided chest measurements in inches of 5,738 Scottish militiamen. And it shows a table of the data, so it has the chest sizes and their counts. And the first question is to make a histogram. Well, the large range, it goes from 3 all the way up to 1,079. So it's a large range, which means it's probably easier and more accurate to put it into the calculator and make it the histogram that way. But to keep in mind, the chest measurements of the militiamen in 1864, the x-axis is going to represent the chest sizes in inches, and the y-axis is going to have the number of men. So keeping that in mind, using the calculator, going ahead and putting in the data of the chest size and count into the first and second lists. So the first list will be the chest size, and the second list will be the count. So once all of the data is in, you're going to go to stat plot and make sure the first plot is on. And when it's on, make sure it's highlighting the histogram type graph, and the X list is going to be the first list or the X values, and then the Y values is our frequency or our second list. And I already went ahead and made sure that the window was a little bit below and a little bit above the mins and maxes for each axis. That way you can see the graph a little bit better. And then you're going to hit graph, and this is what the histogram looks like. The second part of the question says to describe the shape, center, and spread of the chest measurement distribution. So the shape of this is roughly symmetric. Half of it looks like it's on the left side and half is on the right. And to verify the symmetry, you can go ahead and look at the mean and the median by going to stat and then going over to calc and hitting enter. And the first list and the second list, you want to make sure those are highlighted, and then hit calculate, and it shows the mean, and then the median is down below. So the median is 40 and the mean is 39.83, and those are very close, which means that the symmetry is verified. And using that, since we know it's symmetrical, the center is going to be the median, and so the median is 40 inches. And the spread ranges from 33 to 48, as we can see here, from 33 to 48. So that would be our spread or our range. And the second part of this question is, it says, why might this information have been useful? It would be useful in creating uniforms for the militiamen, because you need to know what size to make versus for one person versus the other. The last question is the AP question, and the AP question is comparing 3 rivers, river X, Y, and Z, based on the concentration of aldrin, which is a pesticide, in them, and so in parts per million. So the first question asks to compare the distributions of the concentration of aldrin in the 3 rivers. So first, by looking at the shapes of each of the distributions, they're different for each of the rivers. So river X is skewed to the right, river Y is roughly symmetric, and river Z is skewed to the left. Then when you look at the centers or the medians of each of the box plots, the concentration of aldrin is highest in river X, so just slightly, but it's still the highest, and then river Z has the lowest concentration. And when you're comparing the spreads or the ranges, river X has the largest range and IQR, So it has the longest range, and the IQR is definitely bigger compared to the other two rivers. And River Z, again, has the lowest or the smallest spread and IQR. And also, over half of both rivers X and Y have higher concentrations than all of the concentration of aldrin in River Z. So, over half of each is definitely past this maximum value for River Z. So, the next question gives 20 concentrations of aldrin for River X, and it asks to create a stem plot for these concentrations. So what I did is I went ahead and ordered them in from least to greatest. So from 3.4 all the way to 8.7. And then I put red lines in between the different numbers. So there's threes, the fours, the fives, and then it skips 6, 7, and then the 8s. So when making the stem plot, you put all of the stems or the whole numbers on the left side, and then all of the points on the right side. So the key is 3 to 4 is 3.4 parts per million. And the same goes for all of the rest of the concentrations of aldrin in River X. And the last question says to describe a characteristic of the distribution of aldrin in River X, so back to this River X, that can be seen in this stem plot but not in the box plot. So comparing these two different graphs, you can definitely see that in the stem plot there's a gap in between the 5s and the 7s, and so you cannot see that there's a gap in the box plot. And also the stem plot shows that there's a lot of concentrations around the 4, and here it doesn't show that very much. It shows the ends of the 4 are more in the whiskers. So with that, the stem plot shows a little bit more of the description of how River X actually is concentrated. And with that, that's the end of the Quideo.